Match the following. In column 1 we have the substances like BF3, nickel tetracarbonyl, hypochlorous acid and ammonia. And in column 2 we have properties like dipole moment, back bonding and the type of hybridization and p pi double bond character, p pi d pi double bond character. So then we need to match the substance in column 1 with the property or the type of the bonding from column 2. So let us take A, BF3. This BF3 boron trifluoride is with the central atom boron is in sp2 type of hybridization. So therefore sp3 hybridization is given. So R is wrong. And in this BF3 it is being sp2 type of hybridization with trigonal planar structure. Molecule being planar, the bond moments of each BF bonds cancel one another's bond moment and net dipole moment mu is equal to 0. So thereby P is also wrong. And Q we have is back bonding. So in boron trifluoride, this fluorine atom bonded atom has got 3 non-bonded pairs. And whereas the vacant p orbital exists in central atom boron, thereby this lone pair is pushed into the vacant p orbital of central atom boron, resulting in p pi double bond. So thus there is a back bonding in BF3. So back bonding Q is right. And the type of hybridization we have discussed as sp2, but it's given sp3. So R is wrong. P pi double bond. Just now we have seen there is a p pi double bond between the central atom boron and fluorine. Therefore p pi double bond is right. That is S is right. And it is not p pi d pi double bond. So T is wrong. So thus the option A goes with Q and S. Then when we take B, nickel tetracarbonyl nickel 0. So in this nickel tetracarbonyl, the nickel atom, the central atom possess sp3 type of hybridization. Therefore R is right. Then this nickel tetracarbonyl, we have the carbonyl group tetrahedrally arranged. So thus it is tetrahedral and therefore dipole moment is 0. So P is ruled out, no dipole moment. Then what about the back bonding? In this nickel tetracarbonyl, the lone pair of the carbonyl group pushes this lone pair into vacant d orbital of the nickel atom, and thereby there results in what is called back bonding. Thus Q is correct. And also this back bond is formed between the p orbital of the carbon and d orbital of the central atom. So p pi d pi double bond will be formed. So thus we have T is also right. So thus for B we have R, Q, T as the options. So when we take C, HOCl, hypochlorous acid. Here Cl is considered to be the central atom with the lone pair of electrons. In HOCl, that is in hypochlorous acid, the central atom Cl has got the vacant d orbital and also the lone pair of electrons. And this oxygen also has got the non-bonded pair of electrons. And thereby the central atom possesses sp3 type of hybridization, but with linear structure. And there are lone pairs of electrons, so it will have net dipole moment of some x. So thus P is right. And this oxygen with the lone pair of electrons will donate from its p orbital into the vacant d orbital, resulting in p pi d pi bonding. So thus back bonding is there from bonded atom to the central atom, thereby back bonding, but that is p pi d pi. So back bonding Q is right. Type of hybridization R is right, sp3 only, and followed by T because it is p pi d pi bonding. So C goes with P, Q, R, T. All these are right options. And in D we have ammonia, NH3, and in NH3 the central atom nitrogen possess sp3 type of hybridization, but this central atom nitrogen has got a lone pair of electrons and hydrogen atoms with 3 bond pairs and 1 lone pair. So thus it will have a pyramidal shape. No back bonding. So because of this lone pair of electrons which points in one direction, whereas this NH bond moments point towards the central atom, it will have dipole moment, some y unknown number. So dipole moment is there, P is right, and type of hybridization is sp3. No p pi bond, no p pi d pi bond. So the options for D, one is P, that is dipole moment exists, and the other one is type of hybridization sp3. Therefore P, R are the answers.